right, we're supposed to use a of t, that's acceleration as a function of time, equals negative 32 feet per second as the acceleration due to gravity. Thank you. Now, yesterday they had us do this one, all right, where we showed that if that's your acceleration due to gravity, in other words, you're measuring in feet and seconds, that this equation shows the height of the object. So we're going to use that. All right, V0 stands for initial velocity, S0 stands for initial position. We're assuming that ground level is 0, then something goes up, and after it goes up, guess what happens? It comes back down. I know. There's a song about that, even. So, number 70. A balloon rising vertically with a velocity of 16 feet per second releases a sandbag at the instant it is 64 feet above the ground. How many seconds after its release will the bag strike the ground, and at what velocity will it hit the ground? All right, we need to know initial velocity and initial position. All right, the velocity, the balloon is going up at a rate of 16 feet per second. So when we release the sandbag, if we were just standing at a platform 64 feet above the ground and release the sandbag, its initial velocity would be 0. But we're going up at a rate when we release it. So our initial velocity is 16 feet per second. The initial position, since we release it when we're 64 feet above the ground, the initial position is 64. So the function we need to use then is S of t equals negative 16t squared plus 16t plus 64. Got it from there. Okay? All right, let's see. Our first question is, how many seconds after its release will it strike the ground? How far off the ground is it when it strikes the ground? 0. 64 feet. So the sandbag hits the ground when the position function equals 0. Make sense? All right, we can solve that. Well, I can solve that. We'll see if you can. Factor, take out a negative 16, leaving me with t squared minus t minus 4 equals 0. And I'm feeling really good about that until I realize I can't factor that trinomial. Go ahead, try. You can. So, now, thinking of zero product property, either negative 16 equals 0 or t squared minus t minus 4 equals 0. Well, negative 16 doesn't equal 0. So t squared minus t minus 4 does. Use the quadratic formula. So t equals. Now, b, well, let's put it this way. A is the coefficient of t squared. B is the coefficient of t. And c is the constant. And the formula is x equals, in this case t equals, negative b, so it'll be negative of negative 1, plus or minus the square root of b squared, so that's negative 1 in a parentheses, squared, minus 4ac. So minus 4 times 1 times negative 4, and all of that is over 2a. So all of that is over 2 times 1. Then we start simplifying. Well, the opposite of negative 1 is 1. And under the square root there, when you square the negative 1, you get 1. And then when you multiply negative 4 times 1 times negative 4, you get a positive 16. So we've got a positive 1 plus 16. Well, that's 17. And the denominator, 2 times 1 is 2. Now, we've got the plus or minus. But if we use the minus sign, I'm not sure exactly what the square root of 17 is, but it's just a little bit bigger than 4, right? Since the square root of 16 is 4, the square root of 17 is a little bit bigger than 4. 1 minus something a little bit bigger than 4 is a negative number. So we have a negative time. Well, we haven't released the sandbag yet at the negative time, so that's not the one we want. We don't want the negative one. So only the positive one satisfies our problem. So the question was, how many seconds after its release will the bag strike the ground? It will strike the ground 1 plus the square root of 17 divided by 2 seconds after we release it. And if you want to simplify that, you can. You don't need to. All right? So we've answered part A. You with me on part A? Part B. At what velocity will it hit the ground? Well, if I'm going to find the velocity, I need to know the velocity function. How am I going to get the velocity function? Take the derivative of the position function. Okay? So, the derivative of negative 16t squared plus 16t plus 64 is negative 32t plus 16. Because the derivative of negative 16t squared is negative 32t. The derivative of 16t is 16. The derivative of 64 is 0. So that's our velocity function. So if we know the time the bag hits the ground and we know the velocity function, we can find the velocity of the bag when it hits the ground. So we want v of 1 plus the square root of 17 over 2. So that's negative 32 times 1 plus the square root of 17 over 2 plus 16. Then I can do this, right? Divide that 2 into that negative 32 and get a negative 16. So then negative 16 times 1 is negative 16. Negative 16 times the square root of 17 is negative 16 times the square root of 17. And then our plus 16 at the end remains a plus 16 at the end. And looky here. What's negative 16 plus 16? So that's the velocity of the sandbag when it hits the ground. Feet per second. And if you want to decimalize it, you can. But you see how it actually paid off a bit that I didn't turn our t into a decimal? Because I ended up getting an exact answer with it. And if you want to turn your exact answer into a decimal, that's better than turn it into a decimal up here, because then you're using an approximation the rest of the way, and you never get an exact answer. You never have that option anymore. So we've got the option of using the exact answer or the rounded answer. So, don't round if you don't have to, is the moral of the story. And also remember, on a free response on the AP test, you don't have to round ever. Okay? Even if, for some odd reason, you could give them that as the velocity when it hits the ground, and they'd take it as long as you remember to put. Okay? So use that to your advantage. Now, they might kind of force you to simplify it by asking you something else about it later, but as far as the answer for that question, what I circled in red is perfectly valid for the AP people. Okay? All right. Any questions? And there's your assignment. Start on 256, do 49 through 54, 63 through 72, and 87 through 92.